Okay, so we have two resistors in series, and we could replace that with one equivalent resistance. But there's something else that we can do. We can use this as a voltage divider. So let's use our loop rule. Our loop rule says that the change in potential around a loop is equal to 0. So if I start at this point and I go around the loop, then I will have the first change in potential is EMF. And then the next I have, this is some current I. That's the current I going through R1 is going to be minus I R1. And then the current going through R2 is going to be minus I R2. So I have that. So let's just, I want to solve, let's go ahead and solve for the value of I. So if I do this, I could say EMF equals I times R1 plus R2, because I can factor out the I, and then I can divide by R2 plus R1, and I get I equals EMF over R1 plus R2. Now, suppose I have a voltmeter, and I want to find the voltage across just R1. So I say delta V1. Well, that's going to be I times R1. But what if I use this expression for I? Then I can get EMF over R1 plus R2 times R1. So I can write this as EMF times R1 over R1 plus R2. So let's just say this is equal to 10 ohms, and this is equal to 10 ohms. In that case, I'd get 10 over 10 plus 10, or 10 over 20, or 1/2. So if this was a 4-volt battery, then I would have 2 volts across this, and I'd have 2 volts across this. So I've actually divided, I can do the exact same expression for delta V2. It'd be I R2, so it's just going to be EMF times R2 over R1 plus R2. But you see here that the voltage, the change in potential across R1 plus R2 has to be EMF, the EMF. So this is a way to consider this as a voltage divider. So let's say I want to get 1 volt right there, and then I'd get 3 volts right there. Well, what would I do? What if I'd picked 1 and 3 ohms? So I could say, oh, this is R1, V1. V1 is going to be 4 volts times 1 over 1 plus 3, or 4, and I get 1/4 times 4, I get 1 volt. So you see, it's possible to pick a reasonable choice of resistors to get a voltage I want across one of these resistors. And so that actually is a very useful thing to do sometimes. And that's why this is called a voltage divider.